This lecture is designed for engineers. As an engineer, once you graduate from college or universities, the first task that your employer wants you to do is to create an engineering report. And in a report, you will have data and you will have calculations, lots of calculations from your experiments or from the field work. The sample that I have prepared to show you in these lectures is a lab experiment, and this experiment was conducted on a 10 plus years apparatus, and there will be a massive error. But the main point of these lectures is not to tell you what's the errors, but to show you how to do all the calculations. So let's dive into it. I will start off with a very simple calculation first, such as L over D, length divided by diameter. So this one, I was given that the length was 1, so it's a constant. So I will just type in 1 divided by D will be my diameter. I already typed all of them on the right hand side in column A, so I will just reference that. So 1 over 84, and I press enter, and I will get the result that I want. So once you have one formulas out there, all you need to do is just copy it down the range. There you go, and this is the result that you will get. The next thing to calculate is v squared over 2g. This formula is a little bit more complicated, and the velocity v is not given to you directly. However, you can figure it out by yourself by using these formulas. Q equal to VA. Q is the flow rate, which is this value here, and A is the cross-sectional area of the pipe. Since you want to find V, so you have to rearrange the equations to make it into V equal to QOA. Q is given, but A is not given, but you know that A, cross-section of a cylindrical pipe, is pi r squared. R is not given to you, but D is given. You have to write R in terms of D. So you know that R is D over 2, so R squared is D squared over 4. So you can substitute this value into this R squared, so you will get 4Q over pi D squared. So right now you have found the formulas to solve for V. So now you can take these formulas and substitute into V squared and form these equations. 4Q over pi D squared over 2G. It's a little bit hard to say aloud. This formula is currently in a natural form, but I want it to be in a linear form so that I can easily type it in the Google Sheets. So I rewrite it into this form, a linear format. So once you have the formulas in a linear format, you can begin to type it into the Google Sheets. So I will begin with equal sign. So equal bracket 4 times flow rate, which is this value here, divided by bracket pi times d squared. So d is my diameter, this value here, squared, and then close bracket, square the whole thing, divided by bracket 2 times g is 9.81. So there you go, I get my value right over here. Once you have completed the formulas, you can copy it down the range. But before you do that, make sure that a constant stay a constant. So a constant in these formulas is this H1 right over here. So in order to make sure that it didn't shift, I will put a dollar sign in front of the 1 so that when I copy it down the range, H$1 will stay as H$1 down the range. So once I have do that, I can copy it down the range safely. If you have successfully followed my step until here, that means that you are ready to do phi and k yourself, because the process of calculating and writing it in the Google Sheets is the same. You have to rearrange the equations to find phi, to solve for phi, rearrange these equations to solve for k, and then change them into a linear format, and then type it in the Google Sheets. And before you copy it down the range, make sure that the constant that you want to make sure to be constant always stays constant by using a dollar sign.